Hi, welcome back. So after we got basically familiar with the basics of Visual 3D, today we're gonna get even more familiar with the pipeline commands. So we're gonna get more comfortable with the software and start coding with Visual 3D. So Visual 3D uses pipeline as its command language, and today we're gonna dig deeper into how we can use this powerful tool to analyze our biomechanical data. Alright, so first things first, we open Visual 3D. So I've been playing around a little bit with the pipelines, just trying to make specific pipelines for these tutorials. So when you have already data on your workspace, if you remember, the workspace will basically show you all your view data. Here you will see the model and calibration file on the middle section. Here will tell you like the CMO workspace. I've named it, V3D201, and it was saved. And here you will see the model calibration. So if you have more than one participant, you'll see just multiple of these type of calibrations, and then within each of these participants, you'll see the motion files. So here I have 3 trials for subject S111. So you're familiar with this, and you're also familiar with the signal and events section. We haven't really played around a lot with this, but we'll go deeper today, and then you're very familiar with the model section because we built the model together. All right. So what you don't know yet, and you're not familiar with, is the pipeline command center here. So pipeline processing, you can either click on here or click F11, and it'll bring you the pipeline. So this is the language that Visual 3D uses. It basically creates pipelines that when you just hit a button, it will automatically does everything for you. On the left section here, we have the command section. So Visual 3D has already created commands that makes your life easier, but it also has other commands that you can have the freedom to do anything you want and write any codes you want. Obviously, it's not as open and free in terms of open access, not because it's open access meaning that anyone can use it, but you can do anything you want with it, like MATLAB, for example. You can write any codes you want, you can make anything you want, really, but here it's a little bit limited compared to MATLAB, but it's still a very powerful use. It's still a very powerful tool to complete and run biomechanical analyses. And also, if you remember, I don't know if you've mentioned it, but if I didn't, I mention it now. You can also export data from here to MATLAB and then complete any analysis you want, and then import the data back from MATLAB to Visual 3D and complete running your analysis. So it's also a very powerful tool to communicate and talk with MATLAB. Alright, so again, this is the command um, section. The middle section here is the pipeline section. So you can transfer any commands from the left corner to the middle corner, and then the right section shows you the command and what you are asking the command to do. Alright, so the first things you need to do is, if you remember what we did in the first video, is we loaded and imported all the data and the static calibration and then the model and all of that manually. Here, the first thing I want to show you is how you can do that, but automatically. So it's a nice tool to help you save time. I personally like to do things manually, just in case things so things won't get clustered or get mixed together, especially if you're dealing with a lot of data. Things can get messy easily. But if you're starting a new project, this is a good tool to get you going, I guess. So the first thing here is the command is called file new. So you need to go to the left side where it shows you all the commands, and here just filtered. So it has 289 available commands. Each of these commands have their own use. So first thing is file new. File new, when you type file new, it will bring you that file within file management section. If you can also just type file, for example, and it will give you all the commands that have file in them. So file creation, file import from those, and so whenever you click on that command, it will tell you the description on the lower box. So import events from an from an XLX basically. If you want to import data from Excel sheets, place an event label using target patterns, recognition. So it tells you everything. It's very helpful. But also you can go to wiki here and just type on the search file new, and it will tell you the exact description of that command. So here it says file new, start and fresh, clear workspace. It basically now clears your workspace. So I'm only showing you this because file new is just a very basic one. You don't necessarily need to search for it, but if you need to know any other commands, and it's not really clear of what it means in here, just from the short description, you can search for it on wiki, CMotion wiki. So here it says close all of my files, clear the workspace. If you already, like I said, if you already have data in here and you need to start a new project, then you click on this. If you already are working with a project, you don't need to add this. Alright, so the next command is create hybrid model. This will give you the option to load in the static calibration. So if you go here and just write create hybrid model and filter, you also all the time you have to click filter, because if you click OK, it will just if you hit enter, it will close the entire pipeline command center. So here, create pipeline, create hybrid model. You click on that, it says create a visual 3D hybrid model. It can be used for the file name. You can basically type the actual file name or just keep it like that, and it will prompt up a file explorer, and then you can choose any command you want. Or you can just you can go here and then click text, or just double click on here and bring you the calibration file. Anytime it has explanation point, explanation mark, it actually means that it's not in use. But when you delete that, it will give you the option to actually use that command. It's basically like MATLAB, but MATLAB uses that percentage sign. Here they use the exclamation mark. Alright, so when you keep it like this, it will prompt you to open. So for example, when I step on this, it will prompt you to open any file you want, so it's good to just keep it like that. Alright, the next thing is apply model template. This will allow you to apply a model, from what we created in the previous video on the actual static calibration that you just added from the previous command. So here when you type apply a model template, and then we click filter. This is under model management. It tells here apply a model template.mdh file to a model calibration file, and so on. So, and then and then you can either give it like pop-up never pops up, or like pop-up automatically, or pop-up only on error, you know. Alright, the next thing is to open the file. So here we open, the file open is when we want to add motion trials to that model and calibration file that we just created. Make sense? So if you, for example, here I have 3 motion files, I'm just gonna add all the 3 of those. And then we assign the model to the motion files, if you remember from the first video. So we have that pipeline added here, and then prompt for pipeline parameter values. Now this is a very useful tool to use in analyzing biomechanical data when you have more than one group. So for example, we collected the co-breed data for both older and younger adults, so you can create a tag for older adults, and then you can create a tag for younger adults, and then whenever you want to just run specific analysis for older or younger, you can do that. Or when you want to export some data just for those specific groups, or like divided by those groups, you have that. So here it gives you the option to do that. You can either do it manually, or you can do it by the pipeline. See here, I already created older adult. I can go and create another tag called, for example, add new, and you can just call it younger, and then boom, you have it here, younger. Oh, but if you don't click on any specific motion files, it will go away. So like here, I'm not gonna click on it. If I'm gonna click on it, it will stay, but if you remove it, it will go. Alright. Also, it's not just about younger or older adults. Whatever, you know, groups you have. So for example, we have fallers and unfallers. So those who were slipped but did not fall, and those who actually slipped and fell. And we measure that by the amount of load added to the harness, because we have a load set attached to the harness. And if they add more than 30% of the body weight, then that's considered a fall. So I also did create that as well. So I'll show you later like all the tags that you create, but it's a very useful tool, and I'll show you how we can use it also later on when we run specific pipeline commands. Alright, and the next thing is to assign tags to files. So here I chose all files because that's what I have. And here I only have like older adults, but we can not use all files. We can just, for example, if you go here and concatenate that, it will ask you what files do you want to use. Okay, so let's just keep it like this, and every time you want to just basically run only one of these commands, you click on step, and every time you want to run the whole pipeline, you just click on execute pipeline from here. Alright, after we assign the specific files to the tag using this assign tags to files, we add open report template. You don't necessarily need this, but if you want a specific report, you can keep it. And then I also, if you remember, it is the first step you need to do is to add the anthropometric data for each of these participants. You don't want to start analyzing data without adding their height and mass for each of these participants. That's the first mistake you can do. And it's a big one too, because a lot of these calculations are based on the height and mass of each of these models. Alright, so once you finish all of this, you just hit execute pipeline. So I'm gonna execute it. It basically is, if you can see here, the pipeline, the command center is just the workspace is completely empty. because created new, and then it now it's asked us to create hybrid model. So it went from file new to create hybrid model, and here we want to add the static calibration, so you double click on that. Then I went to apply model template, so the third command, and here we want to add our model. Then I went to file open, so this is the fourth command, which was basically asking us to add the motion trials. So I'm just gonna go to that specific motion file and add those. And then it's asking us now to assign model file, if you can see in the progress um, section. So now we want to add all of our motion files. I'm gonna use all of them obviously, so I added all of them, and now it likes us to add the tags, so I'm gonna, since this is an older adult, I'm just gonna add older, and it's asking us now is assign tags to files. So finish the prompt to pipeline parameter prompt for pipeline parameter value, and then assign tags to files. Now we're here, so we want to assign all of these and hit OK. Now it's asking us to report template. We don't care about that. I don't care about that for now. So, and then now it's asking us for the height. So I'm just gonna put the height and mass, and then boom. So here, once you finish, every time you finish running a pipeline, it will give you a pipeline processing results report, and it gives you the number of errors and number of warnings. You don't have any problems. Sometimes the pipeline works fine, but it'll give you warnings. It means that there's no problem with the actual coding, but you might have some missing data, or you might have some certain like miscalculations and stuff like that. So always like check the warnings as well as the errors to make sure that everything is running smoothly. Alright, so once you finish the pipeline here, for example, when I close this, you see like right now it's the same as it was because I ran the same pipeline. When we go to signals and event, you'll see here there's all files. We can choose any specific file and boom, it works. But if you notice here that all of these I believe I chose, yeah, see, I chose the wrong model. Um, that's why like it's not completely correct, because the model is much shorter than the actual motion file. So you see like the femur and so on, they're not as high as the actual data. So we go ahead and rerun the pipeline. So I'm gonna execute it again, but here I'm gonna choose the actual static calibration. Um, Alright, folder. Cancel. Alright, so now when you close this, we go to the events, should work fine. See? Much better. Okay, but what I was trying to say here is that you see these markers are red, and that means that we didn't run any processing, we didn't like filter any data or anything. So this is raw data. When it's raw, you'll see all of these markers in red. If you want to see the actual names, you can hit on this toggle target labels, if you remember this, and it'll give you all the names. Or you can just go ahead and click on each one of these markers. So for example, the great trochanter, left, and then click on it again if you want to like remove it. Alright, so now the next thing you need to do is you go to the pipeline, and if you need to save it. So you just save pipeline as, I already saved it, and then choose any place you want, and then click save, and you choose the name as well. Alright, so This is just the complete basics. So once you finish this and you have everything on your workspace, the next thing you want to do is condition your data. So data processing, you filter your data, whatever you have completed on your um, motion capture software, you want to finish the rest in here. So for example, I usually use for this project we collected using Mac, and this is for example data from Mac, and everything is basically processed. But for example, if there is like, if you have a gap in here, and in Mac, unlike for example Vicon or Qualisys, where you can add let's say you can add you have like missing data from the end, or from like the by the end of the trial or by the beginning of the trial. In Mac, you only have the option to use virtual joint to use other markers to predict the place of like the movement, and basically interpolate that specific marker, or reconstruct it. But if you don't have other markers, you can't really do it from the beginning or the end. The only other option is cubic joint. So for example, um, if I use this and then just rename it, I can do a cubic joint, which basically just sees the previous and the next behavior of that marker, and then just um, reconstruct it. But if it's on the beginning, you can't really use this cubic joint. So if I remove it and I use cubic joint, you can't, because there's no really previous data. So here, the the other good thing about Visual 3D is that it can do that for you. It can reconstruct, it can interpolate data if you don't have that option when you're processing your data, for example. Or for example, if you just export that on MATLAB, and then you can do that on MATLAB too, you know. But if you have a C3D file and you collected your data from a motion capture software, and that motion capture software does not allow you to do that, you can do that here in Visual 3D. But also, it's mainly used, you know, for other like high-end biomechanical analysis to condition your data and process it. Like the basics are filtering, you know, and interpolations and all those things. So once you save this pipeline, then the next step here is to start the data conditioning. So let's replace this and let's go and start processing our data. So I already created this pipeline, and it's very useful and helpful in a lot of things. So once you have your data here, again, you have the signals and events. We want to, the next step is we want to interpolate our data, and this is what I was talking about. So interpolation, it basically interpolates missing data points of a signal. If you remember, I mentioned that in here in the filter, in the actual command centers, you can click on any command and it will give you what it means in this, in the like in the lower box. Also, when you click on the command, if you already have the command in the pipeline section, also when you click on that, you can also see the description of that in here. If it's not enough for you, then again, like I mentioned, you know, you can go to wiki and it will tell you everything here. So here, interpolate, if there are unreliable data points, like the residual is less than 0, if any and any signals that is possible to interpolate these gaps if the data using a spline interpolation. And that's what I mentioned earlier. When you don't have that option, to do it in your motion capture software, you can do it here in Visual 3D. So, I mean, I like to keep it there, but it's not necessary. If you did a good job in processing your data in your motion capture software, then you don't need to add it here, But it's good to keep it here in case, like, you missed something. Okay? Alright, so we have that. First thing I added, like, file save as. So, if you remember, I mentioned you can add anything. So here I like to basically write everything in my codes and my pipelines, whether it's in MATLAB or like here or any other coding software. It's good to write what each code means and what each specific command is used to run, so you won't forget it later on. So for example here, the BRB gate output data conditioning and gate events. So this specific pipeline will teach you how to condition your data, so like interpolate, process, filter your data, make sure everything is not very noisy, and then it also creates gate events. So if you're collecting data on a treadmill, Visual 3D automatically extracts the heel strikes and toes off based on the force plates on each of the treadmill. If you're using a split bed treadmill, Bertec, and it has like right and left, and given that the participant did not cross over to the other force plate, you should be good to use that. But if you're using like overground data or whatever, like you're using Xsense outside, for example, you don't have that option. You just need to use kinematics. And here the pipeline will use that to run both the automatic gate events that are created by a Visual 3D command pipeline, or we can use Zenny's code. So Zenny is a researcher that does a lot of orthopedic biomechanics studies in Delaware, and he made this. He published this paper in 2008 where he uses the acceleration and the velocity actually of the segments of the foot segment, or you can use any marker from the foot to predict the heel strike and toe off of each side. It's very useful and it's very accurate to the frame. Usually there's only one frame or two frames difference between the actual heel strikes and toe off and the predicted using this method. And actually sometimes it's perfect, like it actually gets it to the point. Alright, so it does that. And here you just write your information, created in December 2022, my name, and then like the actual paper that you're using, and then the command, like the automatic one. You can write anything you want in here. Alright, so then save as. It's always good to use this pipelines as this command called select active files. Now this is what I mentioned earlier about having a very good tool when you use those tags to separate your data by the groups that you're using. So here, when you put select active files, you can just click all files, and all files will basically select all files here. Or you can select any tag that you want. So here we created the tag called older. When I click that and then I run it and I step it, it's just gonna use those. Another very useful tool here also is if you have names like what I've named, those trials from the time that we started collecting the data on the lab, and then when you process it, it's gonna give trim, especially specifically, talking about Mac, but you can, even on Mac, you can write anything you want. But the name is very long. So, for example, here we have in the workspace we have all these names. If you, for example, want to run like select specific data in here, instead of like, for example, if you have like 20 older adults, like what we used, like 2021, but you only, for example, want to, let's say um, you process as you go, so as you collect, and you process like 10 older adults, and then you just collected another one, and you only want to add the rest, just the number 11, like this one, and you've already like processed all the ones before. So you don't want to really like select like all the tag of the older adults, but only you want to select only the ones that you did not really process. So you can either, for example, create another tag that, so what I like to do is create a tag that has analyzed and tag that has not analyzed, and then I just uh, add the not analyzed one to that tag. But for example, if you only want to use one of those, like if you, for example, if you want to only process like S11, S1, trial 2, then you can either write like the whole name here, but if you don't want to do that, another powerful tool here is to like click asterisk and then S111 and then asterisk again and then S1 and then asterisk again, 1, for example, you don't need to write like the whole name. If you just give it numbers, it should technically like do that. So okay, so it actually chose all of them because I also need to write the name. So looks like probably I have to write here like double limb slips and then 1. So let's step it and boom, it actually used that. Cool. So that's what you need to do. Also, you can also rename it. If you don't like these and you just made a mistake, you can rename the um, actual file. So file management, file rename. When you click file rename here, existing files, let's say like this one, here, and then you give it a new file name. You can either like give it a completely new file name, or you remove like, you can remove the file, like the whole file path. I like to keep the file path, so because when you export the data on Excel or TXT and you open that in Excel, it gives you like the whole file path. I like to keep that, but if you don't like that, you can remove it. Like click on here. Um, Also rename set declaration. You don't need to do that. Rename using search and replace. So, for example, here I like this because it gives you like the search and replace. So, for example, we can search for if you don't like double limb slips, for example, like we can just like write double limb slips and then replace that by nothing, and then you hit OK and just step on this, and then it actually went ahead and replaced that. See, like trimmed S11, S1, 1 tracked. So when we go back to the pipeline command center here, and then we like select active files, and then we just like hit asterisk S11, S111, and then asterisk S1, and then asterisk 1, it should um it should have done that, but why didn't interesting. It should have only selected that, but it selected all of them. Let me see, maybe if I do this _1. Yep. So like I said, the problem with Visual 3D, because there is not open access, you'll have to do a lot of trial and error and a lot of outside the box thinking to fix your problems. Like I didn't know about this, for example, but now I tried it and it works. Again, you can be very specific, or you can do this. It's very good because I'll show you later on, you can use a for loop in Visual 3D. So if you use a for loop and you want to, like, for example, only run specific trials and not like run like analyze and not analyze and so on, you might like, you never know, like what you can do later on and what you have to do, and when you feel like cornered and you only need to be efficient with only a few trials, for example, then you have this very powerful option. And also when you have that for loop like I mentioned, you can like run a for loop with only certain numbers and then only replace those numbers, you know, so it will save you a lot of time and a lot of headache. All right, so here I'm just gonna go back um, and add older step, and then we'll have older. I'm just gonna move this back here, we don't need it, but it's also a very powerful tool. Like I mentioned earlier in one of the videos, you cannot delete any data, but you can rename it. So it's a good tool to rename, to be able to rename your data, you know. All right. Now the next thing, like going back to interpolate, again, you know, it's a very good tool and useful if you have missing data, and you can choose like the amount of gaps that you need, and polymer order and number of fits. So it's very good. Now we get to the real business when you need to filter your data. So low pass filter is the most common filter type that is helpful to reduce noise in your data. I prefer to use a low pass filter, a Butterworth low pass filter, um, and here you can use that. So you go and like type in a low pass filter and filter that. It's not gonna give me that because it has to be like this, and even then probably it's not gonna give me, yep, because if you want to like be very specific, you have to be very specific to the point, like with underscores and so on, you know. It doesn't like when you also hit space too. So yeah, so there's Butterworth filter, low pass, you know. So and then you just click on that, it gives you the specific information, you know. Now with Butterworth, with low pass Butterworth filter, you can use like the actual digital filter here. I use Butterworth, and then the cutoff frequency of 10 if you're running low pass filter on kinematic data. I prefer to use 10 frames because I do walking, you know, but it depends on you really, and you can just read more about filters, and you can use any method you want. But this is my preferred one, and the number of samples 6, and this is very important. So the number of bidirectional passes, one is automatically like we give you fourth order Butterworth, and that's what I use. If you go here and then just like run low pass filter on the search command, it'll give you here. So it tells you like low pass filter the points of a signal using a bidirectional filter. The user can specify a Butterworth or critically damped filter. Visual 3D uses a Butterworth bidirectional filter for low pass or high pass filtering. If you specifically want to use just the Butterworth, there is another command for Butterworth. The number of bidirectional passes specified determines the order of the filter. So one bidirectional passes results in a fourth order filter. Make sense? Alright. And here, you know, it gives you more information about how filter works. If you don't know that, but you should know that. If you don't, then you should be taking advanced like biomechanics, undergrad biomechanics if you're an undergrad student, or advanced biomechanics. Or you can just do more reading. Like I said, you know, here it tells you a good amount of information, but if you want to dig deeper, you just read more papers specifically about data conditioning in biomechanics. Alright, so this is what I like to do. And here I'm using this to, so if you notice, I have 4 low pass filters. So I filter my kinematic data and I filter my analog data, so the kinetic. Also, if you have, like here I have this because I also collect EMG, so I basically run the analog for both the EMG and for um, the kinetic data, the force plates. I also have one for the forces, so the force plate data, and for the center pressure. You notice here that I like to use 36, so a higher cutoff frequency for kinetic data, and that's because we sample at 1,000 frames per second, so 10 times the amount of kinematic data. Alright, so then later on the automatic gate events is what I mentioned earlier, and basically it produces these ons and offs. It actually uses like right on, right off, which is right heel strike and right toe off, based on the load, the ground direction force data, or like the force plate data. Here I just basically deleted event delete. You can delete any events. Events here are referred to specific time points, and you give them a specific name. So for example, when you go here, you see that I don't have any events, and that's because we didn't create any events. But usually you'll see events in here. Before we start, let me introduce you to what this means. So when you go to the signal and event section, like I mentioned, you see like your motion trial in the middle, and you have your time but down below here with the time in seconds over here, and like inside here is the time in frames. So I have 55 frames 0.54 seconds, and that's because we collected and recorded at 100 milliseconds. I mean 100 frames per second. So you can also find that in parameters here. So when you go to parameters, you when you go to parameters, you have the subject points. Yeah, so here if you go to point and you go to rate, it should give you the frame rates per second, so 100 here. When you go to analog or force platforms, wherever, and you go to rate, it's gonna give you that rate of that specific. So analog is 1,000. If you go to also the rate, okay, it doesn't give us rate for force platforms, but it's the same. So you find very useful information here as well. Also, when you go to header information, it will give you that same information. So sampling rate here is 100. It also gives you the amount of frames. So like the last frame is 490. First frame is 1. It gives you the amount of channels for the analog, and so on. It's very useful. Frame number also gives you here, like if you just want to go to the frames, it gives you the analog time. And here when you go to the analog, it gives you like frame number, original analog time, 1,000 hertz. And then the frames for the kinematics, it gives you here as well, so 100 hertz. If you're not familiar with motion capture, you need to know that basically the analog is always a multiplication of the kinetic is always a multiplication of the kinematics. So when you go to collect, for example, you said like the sampling frequency for for your kinematics are at 120 frames per second. When you go to choose your kinetic, you have to only multiply. You can only multiply that. So if you want it to be 1,000 to 100, then you just multiply it by 10. But if you want it to be 1,000, just 1,000 frames per second, then you have to do a little bit of math in there. Here it gives you the metrics of the participant, and here it gives you the kinematics and kinetic. Let's first start with the beginning. Like the target here, target is just the raw marker data. So if you go to for example, the head marker, the anterior head marker, it gives you the graph in here, and gives you the data values, the actual data in here, and it gives you the signal processing history. For example, because it is raw here, you don't see anything. But once we start running like filters and so on, and like other stuff like that, it will give you like all the all the steps that we did in here. So it's very good to also like track down what you did if you forgot. All right. Another thing that you can is very good here is that when you hit Control and then click on it, it will give you all the data on the graph section on the right side that is synchronized with time to the actual data. So if we move here, you'll see like the line moving in accordance to the actual data, and you see like your to the actual motion file, and you can see your data there. All right, so that's the target, and you see you only have original now because we only have original, and you can click on this plus or minus sign to expand or minimize, and then we go to the analog. The analog section here has all your analog data, and automatically Visual 3D does this for you, and you have, for example, force plate 10, and in the Gait lab you have the forces here, so 1 2 3 4 5 6 7 8 9 10, and also you see it's written here as well. So you have like here FP5, so we have force plate 5. If we want to look, for example, at force plate 5 data, you can either look at it from the analog section, and you need to go like find like F5, but the problem here is that when you click on F5 Z, it only gives you that one um, um, like one axis, either the X or Z or Y. It also gives you the data opposite as well. So if you want to get the raw data, you go to force, and then you just choose the force plate. So if you want to go to force plate number 5, you just click that, and it gives you like the X, Y, and Z coordinates and the right data. But you can do anything you want. Like if you just want to use the specific analog, you can use that and then flip it. Just multiply it by minus 1. The also good thing here is that you'll have all of your data because we use the load cell data. We have the load cell data here, and the load cell data here are or were basically recorded in volts. So it's a maximum of 5 volts, and 5 volts is the participant's weight. So if they pass like 1.5, that means they passed the 30% threshold, and that means they fell. We also have the trigger here, which basically measure the trigger when we trigger the wasp to slip people, so we have the exact time when the wasp is triggered. That doesn't mean specifically so you have a lot of useful tools. So again, this is the analog, and we only have original because we didn't do any analysis or further anything. We have the forces in here for the force plates, and it also is also good that it also gives us the center pressure. So when we go to force plate 5, you see the center pressure here. So you can see like there's no data before they stepped, and then they stepped here, and you see also you can visualize the data here as well. The blue arrow is the forces, the ground direction forces, and here we have the X, Y, and Z. So the Y is the AP, and you can see here in the Y how they transformed the center pressure from the heel to the toe, and then again they landed with the toe. That's why you see more center pressure. So it's very, very, very powerful, when you're trying to be creative, visualize your data, try to analyze specific data, and also you can graph them here and see if it makes sense or not. The first thing you need to do also in biomechanics is to visualize your data and make sure it makes sense. That's why I don't like to um, like run my pipelines automatically, because it leads to more error. But whether you do that or you do it more manually, you have to go back and check your data. All right, the next thing is this free moment. So also Visual 3D like creates moments. Obviously I don't use this because we run like specific joint moments or like moments around the center mass, stuff like that, so I don't usually use this. We have the landmarks later on. So the landmarks are all those virtual markers. If you remember, like these green like virtual markers, you can find them here in the landmark. So it's also very useful and powerful to have those data as well. So like you can have like the graphs and the actual data here. It's very powerful. Alright, then the next thing we have the kinetic and kinematic data here. So because when we create those specific segments in the model section, each of these segments, Visual 3D creates all of these data for each of those segments. So for example, when you go to like the right foot, we'll have Visual 3D automatically creates the angular acceleration, the angular velocity, the center of gravity, the acceleration of the center of gravity. So basically it creates the center of gravity of that foot segment, and then it measures their acceleration and the velocity and the position. It's very useful to use that if you want to run specific like analysis for the whole segment and not just like one marker. It also gives you the distal end position and the distal end velocity. This is useful if you're running like a specific biomechanical model like margin of stabilities, for example. If you know margin of stability uses like the position of the center of mass plus its velocity, accounting for the inverted pendulum, which uses the velocity of the center of mass, but also the inverted pendulum by measuring the distance between the center of mass and the foot. So it creates that vector, and then measures the velocity of the center of mass as a pendulum, as an inverted pendulum. Add that to the position of the center of mass, we get the extrapolated center of mass. The extrapolated center of mass is basically the position, it's estimating where the position of the center of mass will land based on its velocity. And if the position of this, if the extrapolated center of mass lands outside of the base of support, which here you can use that as either of like any of the markers you use. For example, if you're measuring the sagittal plane margin of stability and you want to see if it's within the base of support, basically in front of the heel marker, like right here, this one, come on. So you can either like use this heel marker. Sometimes it gives you like, sometimes it's like a pain in the ass like here, but you can just click here and it will give you a name. So you can either use like the left heel marker, or you can use the distal end position here, which basically it's the same thing, because you create the foot segment as the using like these markers, so the heel and the toe and so on, like Arcanius. It also gives you the torque and the velocity and the residuals for each segment. So it's really useful, and we'll get to that in a little bit. Alright. Besides that, it also gives you the center of mass as well. It automatically calculates that for you. And from here, we can get the velocity, the acceleration, and so on. You can measure a lot of things. Then we have the metric section. The metric, again, gives you back to what we talked about earlier. So the height and mass, and then they have the frames, they have the information, and so on. Okay, so now you're familiar with the data section here at the signal and events panel. The next thing we need to do now is go back to our pipeline command center and continue with our pipelines. So event delete here is because I already create, I run this pipeline multiple times. When I run it for new data, if it already has created that for me, I just delete them and then start over. Now we start by computing model-based data. Now if you don't know what this means, it tells you here. Compute a signal using a model segment, kinetic and kinematic data. The order of the rotation of the cadent angles can be specified by the axis. So if you want to change the order, you can. But this basically creates a signal using the model, And again, because if you remember, the kinetic and kinematic section creates those specific segments for us based on the data based on the segments that you created from the model section. You can use this to basically we're using this to create the velocity of the segment. So here Zenny's code uses the velocity of the foot to predict the heel strike and toe off. So when the foot it's in forward motion, and then when it's about to touch the ground, it goes from positive acceleration to negative acceleration. So that's why we need the acceleration. And then when it's toe off, it goes from either negative or 0 to positive. So first of all, we needed here to create the velocity of the right foot and the velocity of the left foot, and we use the first derivative. So we extract the position of that here. So here segment position right foot virtual. So we're using like the actual ground one. I prefer to use that because it's actually on the ground. We basically, like, if you remember, we just basically change the z coordinates to 0, but keep everything else the same. So we extract that position, and then from that position we create the first derivative. So first derivative command will give you the first derivative. So if it's position, it will give you the velocity. If you use the velocity, it will give you the acceleration. But you don't need to do that because there is a second derivative, to extract the acceleration from the position. So here, a good thing about commands in here, you can just double click on it and give you like a more user-friendly thing, or you can go to text. I usually go to text. I like it better because you can type anything you want, you can code anything you want. So first thing it will ask you about the signal type. So signal type is the name here. So target, whatever, analog. You want to go to link model based, and that's because here it actually asks you for the signal types to export this. So when you export that, yeah, it asks you that because we already like created that here. So again, when we first go back to the first command, compute model based data, again, commutes a signal using a model segment. It will ask you for the result name, the function, the segment. The segment, because it already knows where it will find that, you don't need to like actually write the signal type. It knows that all these segments are within the kinetic and kinematic. So when you run this, it automatically gives you basically automatically creates a new folder type that is called link based model here, link model based. So when you, for example, in a step it, you'll see here you have no errors, no warning. You'll see that it created like one here. See, link based model and then original and so on. So to call this specific signal, when we want to extract the velocity of this specific position, then you have to, now when you go to text, you have to type within the signal types, you have to type the specific type, which is link model based. That's the folder name. And then under that you go to the folder within that type, which is original, and then you type the name. So left foot like velocity, left foot center of gravity basically. Also, you can either like want it for one like signal, or you can create as many signals as you want. And you do that by adding a plus sign, and then again you do the same thing again. So you type the type, and then type the signal folder, and then type the signal name. And then when you keep these like this, it will automatically create a folder called processed within that same place. If you keep it. Otherwise you can give it like a new type, it doesn't matter. You can create a completely new folder, you can add it to an already created folder, and so on. And then when you just hit underscore, when you type underscore and just whatever after, it will keep that same name and add just like the thing that added to it. But you have to type true to apply a suffix to original signal. If you don't do this, it will just give it a name like here, velocity. So if I keep it like this, for example, let me also step this. Now you have both, and then I'm gonna go to first derivative. I'm gonna keep it the same. See, it creates a new folder called processed, and then gives it like underscore velocity to the actual name. But if, for example, I go here, and again, if you If you want like a more user friendly, you can just keep it like this, and then unclick here. Or if you want to go to the text, you can just, if I concatenate, for example, if I concatenate this and I click OK and run it again, it will give me like a velocity, you see. But it only gave me one because I did not add a plus sign. So if you want to give another like one, so just let's say velocity 2, and now I should create both of those. See, like velocity and velocity 2. So it's not very like complicated. You just need to get used to it, you know. It's actually much more user friendly, but also it's very powerful because, you know, when we get into more, like when we get deeper into more how to create your own models and how you can create your own code and so on, you have basically like the sky is the limit. You can do anything you want within like the commands that are provided here, you know. That's why I said, you know, if you're trying to like run very high end like models and you're having troubles like finding it, although as far as I'm tried, you know, I've been able to do everything in here unless, you know, um, it's a specific library that I can only use in MATLAB or like any other coding languages. Then I export the data from here, then put it on MATLAB, um, and do it there, you know. All right, so I'm just gonna go ahead and like remove this back to normal and keep it as is. So that's what you do, you know. Like now since we created the velocity, we low pass filter that specific data that we just created, and then we're creating the threshold here. So we create the right to off. So event threshold basically creates events for you um, using specific thresholds. That's why it's called event threshold. So when you go here and you type event threshold on the command center, um, on the search bar right there, it will give you this. So each of these specific commands you see here are explained thoroughly by CMotion wiki, because I've done this a long time. I know what exactly it means. So again, you know, you can double click on this and it's more user friendly, or you can hit text. I like to go with text. So the first thing here is the result event name. So you just name it whatever. Here we're trying to export, we're trying to extract the right to off. So the right to off is the name. We use the signal type of link-based model, the signal folder of processed, and the signal name of the right foot, the velocity of the right foot, center of gravity position that we just created now. Okay, you can either create it yourself, or you can just actually just use the one that Visual 3D created. But if you do that, you need to make sure that the signs are correct, you know, because Visual 3D creates those based on the coordinates of the lab. So if the person is walking north or he's walking south, it's gonna be different based on the direction they're walking, you know. So make sure all the time, you know, like again, I can't really stress this enough. You have to always go back and recheck your data and make sure that everything's making sense. Because with the amount of data that we're using in biomechanics, it's just crazy, you know, how much data we use, and it's just too much for one person to not have any like human error, you know. All right, so then we choose the component of y because we want the sagital plane, since that's the walking direction. If you're doing like lateral stepping, then you use the, y, you know. It depends on what data you're using. If you're using Gait, then make sure you go the right coordinates. And then here we set threshold of 0, because again, and like I mentioned, it's the right off. So Zenya's code uses the velocity of the foot to predict the toes off and heel strikes. When it's toe off, it predicts that by predicting the velocity when it goes from positive to negative, from negative to positive. That's the to off, and that's why we use here threshold of 0 on ascent. Yes, because we're trying to go from negative to positive or from 0 to positive. On descent, false. We don't want to do the opposite, so that's why we put false here. And we give it a threshold of 0. So if anytime it passes that threshold of 0, we will indicate it. We also give a frame window of 12 frames just to give it option. So basically, it basically looks for 12 each 12 frames windows. And then ensure frames before true and ensures frames after true. That's the frames before and after the threshold of 0. So if you want to like understand more about that, so for example frame offset 0, if you want to offset certain frames, time offset, you can go by either frame or offset, by either frame or time, which means that basically whatever you just give it, you skip whatever frame or time you want. Event sequence, if you want to just look at like the toes off, for example, and heel strike only between certain sequences. So let's say like you create an event of start and then create an event of stop. That's the only frames that you want to look for. For example, here we have like a few, for example, few empty data points, and then we go and then it ends here. So for example, I can go and create a frame in here. Like I go to the first frame where we actually have data here, frame 52, and you can either do it manually or by pipeline. When you want to do it manually, you go to the event plus here, show or hide the create event dialog, and then here it says show or hide the edit event dialog. Just click on the first one that has like a plus sign, and will give you all the events that are here that you can, that they already make your life easier. And this is because I've already like created many. That's why you see a slip start and so on bad. But if you want to like create start, just type start, and then you can either like create an event at current animation frame. Let's go to 53 when it actually starts. Or you can like manually type the event, and then boom. So like how now, because we actually created that, you go to like an event label type has been created. Within that there's a folder of original, and then within that there's the event that we just created, and then we can like create another one that is called stop. um, and then we go all the way to the end and then create an event at the station at the specific time point. If you want to create an event using a pipeline, just go here, type create event, I believe that's what it's called. Nope. I think it's event creation, yeah. Oops. We'll see what it's called. So event, so within event creation, and maybe event explicit, create an event label at a specific point frame, specific either by frame number. Yep. So you just like double click on it. When you double click on it, it will automatically go there, but you can do it this way as well. So event explicit, and if you want, for example, to put it in anywhere you want, you just like, for example, here it will go after it. So there you go. So and you also you can like rearrange them here by these two like clicks in here, so let's just put it all the way up, and here event explicit will tell you like create an event label at a specific time point. You can either like do it more user friendly and like do the name here like stop, and then you can either go by frame or time, and let's say like 264, and then I'm gonna hit done, and then here you go. Or you can just click text and then do it this way as well. Let's go here and then delete the event. You can either delete it by right click and delete, or you can go here and go to stop and then remove event No, this is like just removing it from the list. Okay. Yep, so that's fine. Let's just go here and then delete. I usually delete from here. And then like when you go here and then step it, will automatically do it again, you know. So here. Cool. So we go back to the I'm just gonna remove this and we go back to the event threshold section, and the event threshold here, it asks you, for example, event sequence. So you can just either keep it for the whole trial, or you can just write here like start plus stop. Sounds good. But also you have to like remove the list so it works. But I'm just gonna keep it like that. Event exclude, you can exclude certain events and so on. You know, it gives you all the information here. So um, like the offset, for example, like a frame offset, the frame offset from the threshold crossing where the event label is to be placed. So for example, if it does cross like the threshold of 0 at frame 55, you know, if you give it an offset of 1 frame, it will choose the 56, not 55. Event sequence, like I mentioned, you know, exclude events at the and that falls within the event sequence. Event may be specified to exclude a sequence from the calculations, you know. It's very useful. You'll know like these when you start using more and more Visual 3D, you'll see how useful these things are. So we do that for the right toe off and the left toe off, but for the right heel strike we basically flip it. So it's the same thing, but it's on descent. So when it goes from like positive to negative, then we pick that as the heel strike. Alright, so we do that for right and left. I also added the trigger because I wanted to extract the event when the wasp is triggered. And then here switches switch between tabs. The switch the current view to workspace signals and events. If you, for example, have it in whatever workspace, you can switch to the signals and events so you can actually see the data. I made that here so you can also create the specific graphs that you want. Here I created 2 graphs for the left heel, the right heel, and I highlighted like, and then I highlighted all of them. So the reason why I did this is when it finishes all of that, it automatically like switches to the signals and events section, and it automatically will add the graphs of the right heel and left heel, and it highlights all of these so all of these events, so left heel strike, left toe off, and so on, all of these highlights them, and it breaks the pipeline, so I can check visually if all of these specific events were correctly created or not, you know. So let's go ahead and run this pipeline, execute it. Okay, let me just double check I have everything correct. So it seems fine. Alright, so everything is fine. I'm just gonna execute it. It's gonna ask me to save it. I'm gonna go ahead and save it on the desktop. I already saved it, but it's fine. And that's because I actually like recorded like a 1.5 hour video and it didn't save, so that was heartbreaking. Alright, so here she stopped the pipeline and they gave us this. So let me just, for example, close this, and you can see all the data. So for example, if I go to like the first one, again, you know, also like didn't give us any errors or warnings, so I'm just gonna close this and sees, and here I basically wrote look at the graphs, and then if for example you have more pipeline to go, then I can either like hit resume or halt the execution. I'm just gonna resume it because there's nothing after that, but you see the first thing you notice here is that these specific markers are gray now because they're not red anymore because they're processed, you know, they're filtered, they're not row anymore. And also, I read, like I told you, I've made sure that the pipeline will show us the left and right heels markers and graph them, and then it highlights all of these events. It automatically chooses the colors for you, so you don't have to think about that. So here, for example, if we look at the left heel strike, which is blue, and we look at the left heel here, so it starts with the left heel here because it doesn't really have data. That's why it doesn't do a good job. No, actually here. So it starts here with the left heel. That was the right, but I was talking about the right. So here the left foot, and it chooses this specific point as the left heel, which is very good. But if you want to check this data with actual like force plate, so this is it. If you look at the left on, I can actually the right on, so I can just also highlight this. So the right on is red, and the right heel strike is like the blue. So you see like the right on and the right heel strike, there's only like 4 frames difference. It's not very bad. It's actually very good. um, let's see the next left heel strikes. The next left heel strike is here, and so it actually chose that almost perfectly, and the left on is right next to it. See, so this is right here is the left on, and this is the left heel strike. So there's only 1 frame difference between them. So it does a very, very good job. All right, so you check your data, it's fine and good. Then you're satisfied with that, you can go ahead and save it. Save the workspace because you saved it before. If it doesn't make sense, it's always good to like save it as, so then you always have the data before. All right, the next thing I want to show you here is that like also if you just click on any of those, it gives you the exact times. Okay. All right, let me keep this on. The next thing I want to show you is that when you go to the target, for example, then you have the original here. If you just want to use the original data, you always have it. The next thing is the process. So once we um, process the data, we created like a new folder called processed, and you'll have the data here. Also, if you remember, like when I told you the signal processing history, it tells you exactly what we did. So here, it tells you that we actually interpolated the data, and we low pass filters as well, and it shows you the exact code that we used. So if you want to if you're not sure what you did or like whatever happened, you can always go back here and check what happened. The next thing here is that although there is like a pipeline that exports all the data for you and like very organized fashion, we'll go through that in a little bit. But you can also, like for example, if you just want to use this data, you can copy it to clipboard, and then you can just open like a new Excel sheet and then just save it here. So once you save it, it gives you like the target, so the actual like name of that outcome measure you're using. It gives you the file name, and then the frame numbers here, and then the data. Sounds good? Alright. Let me just close this, I don't want to save it. But once you export, like when you export the data using a pipeline, it gives you the whole command path, the whole file path for the specific files you're using. Alright. And this is the same thing, for every other data you use. Alright. Okay, so with that, I'm just gonna end the video in here, and then the next video will go into more details of the specific pipeline commands that Visual 3D has, to extract like joint angles and joint angular velocities and stuff like that. It's very useful. Um, and we dig deeper more into these command pipelines. But this is still the basics of getting to know the commands and the pipeline and the coding language. And once we finish with this 201 and 202, we'll go into like how you can code specific biomechanical analysis, or like whatever you want to do, you can code them. I'll also provide these specific pipelines to you so you can use them if you want. All right, well, thank you so much for listening, and I hope this helps. Also, again, make sure you save it, save pipeline as and so on. Okay, all right, thank you, we'll see you soon.